Hello there, welcome to our 6th unit, log functions. We're going to look at the basics of logarithmic functions today in lesson 1. So we've worked with exponents before. Logs are very related to exponents. They're kind of the opposite of what we were doing before. So if we remember 2 to the power x, so a base 2 with an exponent x, the variable x will be changing. The domain of that was XER, right? You could plug in any number into that X value and you would get an answer. It would be really small with the negatives, but you would still get an answer. And then the range, so what we remember about exponents is we can't have an answer in the negatives. Okay, so 2 to the power x, no matter what your x value is, you'll get a positive answer. With logs, we can see that these are related because it also has a base 2. Basically, what we're doing is switching the x and the y, and we'll get into what is a logarithm in a minute, but we're just switching the x and the y, and what that means is we're going to switch our domain and range too. So now x must be bigger than 0, but the y's can be any real number. Okay, so let's look at base 10. Okay, doesn't matter that the base changes, the domain and range stay the same. Y must be bigger than 0. And for the log base 10, x is bigger than 0, range is YER. Okay, what if we flip the base into a fraction? Again, doesn't matter what the base is. Our domain for the exponents, the exponential, will be XER, or y has to be bigger than 0. And with the logarithm, again, x is bigger than 0, range is YER. Okay, it doesn't matter what our base is. So what is a logarithm? A logarithm is finding the exponent to which a base must be raised to, so must be raised to yield a given answer. Okay, so basically, if we look back up here, base 2, with the exponential, you could have 2 to the power, let's say x is 3. So 2 to the power 3 equals 8. So y would be 8. With the logs, the x and the y switch. So it would say y is, what is y when log of base 2 is 8? Okay, so the y value is what is the exponent that the base is raised to give the answer of x. So again, the x here in the log would be 8. It's saying 2 to the power what equals 8. That's what logarithms is doing. So it's the opposite. So let's look at this further. If we have fx equals, let's go base 5. And we'll do a blue one. Fx equals the log of base 5. Okay, we'll make a quick chart. So we have x and fx. So our answer, let's go -2, -1, 0, 1, 2. Okay, 5 to the power -2. Remember, negative means flip it upside down, the reciprocal. So we'll get 1 over 5 squared is 25. Okay, and then 1 over 5 to the power 1 is 5. Anything to the power 0 is 1. 5 to the power 1 is 5. 5 to the power 2 is 25. Great, so let's graph that. So when x was -2, we had 1 over 25. So there's a very small answer. Negative 1 was 1 over 5, which is still 0.2, so it's also small answer. When x was 0, the answer was 1. When x was 1, the answer was 5. And 2 is 25, which is way off our graph. But our exponent graph would look like this. It's going way up. Okay, for logs, so x, fx, so we're just changing it. So this is working backwards. So when x is 1 over 25, the answer is negative 2. And when x is 5, the answer is negative 1. Okay, so hopefully we get comfortable working with logs, but if it's tough for some of us, you can literally just make the graph with that base and just for your log graph or chart, sorry, for your log chart, just switch the answers. Okay, so what does this one look like? Okay, when x is 1 over 25, so very, very small, y was negative 2, then negative 1. When x was 1, it was 0. When x was 5, we had 1. When x is 25, it's 2. So you can see it's the complete opposite of the exponential. Okay, let's evaluate. Evaluate log base 3 is 9. Okay, so it's asking 3 to the power, so this is the same thing as 3 to the power what equals 9? Well, we know that 3 to the power 2 equals 9, so x is 2. Okay, so this is 4 to the power what equals 1 over 16. So the 1 over tells us our exponent is going to be negative, and 4 squared is 16, so x here will be negative 2. (49 to the power what equals 7. Okay, so this is backwards, and we know that the square root of 49 is 7, and based off prior knowledge, the square root exponent is 1/2. And finally, 3 to the power what equals negative 2? Well, as I mentioned before, and we look up here at our logs, it always has to be positive, our x. So this is undefined. Good. To sum up, let's fill in the blanks. When b, the base, is greater than 1, the exponential function y equals b to the power x is an exponential growth function. And the logarithmic function y equals log b to x is also an exponential growth question. When b is in between 0 and 1, the exponential function y equals b to the power x is a decay question. It's exponential decay, but same thing. And therefore, the log function log b to x, if b is in between 0 and 1, is also a decay question. The horizontal asymptote of a base exponential function is y equals 0. Right? If we look back at our graph, that red line gets very close to 0 but doesn't actually touch 0. So that's the asymptote. And in a log equation, the vertical asymptote is at x equals 0. Okay, since the y-intercept of an exponential function is 1, right? Anything power 0 is 1. The x-intercept of a log function is 1. Okay, and the domain of a log function is XER. Oh, sorry. The domain of a log function is x must be greater than 0. The range of a log function is YER. Okay, those are the basics of log functions.